Hi, everyone. My name is Ethan Cowan, and the title of my presentation is Ethics and Bias in the Real World. Now, for something completely different, our friend here is going to be handing out bags of Legos. If you would like to play with Legos, raise your hand. We've got 25. All right. Wait, don't. OK. And this is connected to the presentation. It is not a distraction, I promise. OK, so ethics and bias in the real world. And a bit about me. Nice. A bit about me. I just killed the computer. What does this mean? OK, we're back. I work mainly in machine learning and software engineering. And I'm also working on a master's degree, and my thesis is related to how to develop machine learning models that do not discriminate. And before I continue, round of applause for the Lego giver outer. Thank you very much. Greatly appreciated. So this talk assumes that you have no background in machine learning. You don't know what a machine learning model is. I'm doing that for the sake of maximum explanatory power for everyone here. So for the purposes of this talk, I'm going to define a machine learning model as something that learns to detect patterns in data, and that can then be used to understand future data that is incoming. So the classic example that I like to give is if you are trying to classify fruit and you get a fruit that is red, round, and has a stem, it is more likely to be an apple than an orange. Why do we know this? Because we have all experienced apples and oranges before. Now, does everyone have your Legos ready? All right, where are our Lego friends? They're all OK? You got them ready. Oh, you've already built something. Nice. All right, you're a step ahead. All right, here's the challenge. You have 60 seconds. Oh, right, I have to use this clicker. You have more than 60 seconds. You have 1 minute to build a duck. And while you're building the duck, I'm going to stall and hope that something happens. That is the challenge, and this is going to be connected to the talk some way. So back to what I was saying previously. For our purposes, machine learning is equivalent to statistical learning. It is, for those of you with a math background, doing linear regression would be a simple example of a machine learning model. You have some data, you learn the slope that is connected to it. The timer wasn't running, so you're going to get 20 free seconds. So, all right, let's see. Has anyone made progress on their duck? That looks like a duck. That looks like a duck. That's 3, 4, 5, 6, 7, 8. Raise your hand if you're not done with your duck. No pressure. OK, so if you are done with your duck, I would like you to come stand somewhere up in the front, not in front of the projector. And we are going to compare our ducks. Do any of these ducks look exactly the same as the other? Yeah, watch. Apparently the projector is a laser and you shouldn't look at it or something. OK. Wow, OK, this is good duck progress. Look around. Do you see a duck? That's an interesting one. We've got Picasso over here made a duck. OK, do any of these ducks look exactly the same? No? Yes? Anyone? Bueller? OK, so thank you all very much. You can, if you want to line your ducks up on stage or take it back to your seat with you, if you have a name and have grown emotionally attached to it, that's fine. So why are we doing this? Here are 5 potential ducks that you can make with these same 6 Lego pieces. I bet that none of these ducks look like the ones in this picture, and none of them look similar to each other as well. And that's OK, because there's an enormous number of ducks that we can create with the same 6 building blocks. Now, the next question is, do any of your ducks look like these two? Right? Well, this one is the same color, but it took a lot more Lego blocks. So none of them are going to look like this one, and the bill is a different color. And this is a mallard, so none of them are going to look like that, right? The head is green, it has some babies following it. But when I told you to make a duck, you immediately went for something resembling yellow. Usually the red pieces are used for the bills or for the feet, because that is more or less the input data that you were given. So your resulting duck approximation depends heavily on the choice of Legos. Without other colors, shapes, and quantities of blocks, it is impossible to develop certain approximations of a duck. So why are we talking about ducks? If we replace the word Legos with training data and algorithm, and we replace the word duck with model, then we can conclude that your model depends heavily on your training data and your approach. I started with this exercise for two reasons. One is that I was curious to see what 25 abstract ducks would look like, and also because I wanted everyone to get comfortable thinking about the central role that your data is going to play in your machine learning model and your resulting duck model outcome on the stage here. So a bit of brief history. In the past 10 years, graphic processing units, or GPUs, have become much cheaper, and cloud services have become much cheaper as well and much more prevalent. So we now have applications including recommendation systems, for example, in Netflix, and targeted advertisements that are gleaning information out of very large amounts of data that we are generating. But they've also been used in things like mortgage underwriting. But hold on a second. If models are trained on data and data is collected by people, what happens if the data is biased? So the technology is now impacting us in ways that it hadn't even several years ago. In the case of mortgage underwriting, there has been extensive work in the use of artificial intelligence. And in the case of healthcare diagnoses, there has been a lot of progress as well. And more businesses are relying on data to build models and make predictions. So when I tell people that I'm studying the ethics of machine learning and technological ethics more broadly, I've heard this response over and over and over, and the line is always, quote, "But a computer can't be racist, it doesn't even know what race is." But this is part of the problem, is that a computer doesn't have the cultural context and conscience to make clear, distinct decisions with harm minimization in mind. And in general, there's this misconception that technology and artificial intelligence represent some sort of platonic ideal of decision making, since a computer can't discriminate. Or change the slide, apparently. There we go. So this is a sample of two headlines that have been published in the past year and a half. One is from Vice, which is, "Algorithms have nearly mastered human language, why can't they stop being sexist?" And the other one is, 600,000 images removed from AI database after art project exposes racist bias. Now, what these two have in common is that they are feeding in data that essentially encoded the bias of both society and the individuals working on it. So this raises another question, which is, we're not saying everyone who has ever built a model is deliberately trying to be as discriminatory as possible. Quite the opposite. It's usually out of almost accident. People just don't think about these things because the data frames your point of view. This is a particularly notorious example that is out in the wild already. This is a tool for generating risk scores for imprisoned individuals in order to make decisions based on decisions for sentencing. So this is called COMPASS. It is the Correctional Offender Management Profiling for Alternative Sanctions. If that didn't make sense to you, it doesn't make sense to me either. It basically calculates risk scores for recidivism, where it defines recidivism as being rearrested after being released from prison. Now, there's a couple of problems with it. One is that the algorithm is proprietary. You cannot open it up and see exactly how you're being judged. Before I continue, I would actually like to get, if someone sees something about this that they like or dislike, you can raise your hand and basically shout it at me because I don't have a microphone to give you. If anyone has a very strong opinion about this, I do want to open the floor up to a discussion. But I don't see anyone's hand shooting up, so okay, yes, my friend from lunch.
The number of arrests and first age of arrest is very biased towards people. Yes,
this is actually in the ProPublica report, which that's an excellent point, was raised in the ProPublica report, that your age of first arrest and number of arrests before the age of 18 are highly correlated with growing up in a minority neighborhood due to over-policing. I saw another hand. Yes?
Also family history and education level.
Yes. Yes, yes, correct. So this is another huge problem in that there is a stark correlation between socioeconomic background and race in terms of there's even questions about was your father present in your life, was your mother present in your life, did they complete high school, things that go back a previous generation. So what you need to know about this is that it is being used and it is making decisions about people being released from prison. It was also the center of a lawsuit. So in the state of Wisconsin, a man named Eric Loomis was accused of being involved in a drive-by shooting. And I'm going to quote from the Harvard Law Review here. Quote, "The trial court referred to the compass assessment in its sentencing determination and, based in part on this assessment, sentenced Loomis to 6 years of imprisonment and 5 years of extended supervision." Now, the compass algorithm is a trade secret, as I said before, so only estimates of its internal workings can be known to the general public. Mr. Loomis challenged the conviction on the grounds of violating his right to due process. The Supreme Court of Wisconsin essentially agreed that it was a problem, but their solution was to mandate a warning for all users of the software within the justice system, which, as we all know, when you see a warning in a piece of software, you close it as quickly as you can and do whatever you were going to be doing anyway. It's like the terms and conditions that we all read. But they did not ban its use. This was challenged up to the level of the Supreme Court, which declined to hear the case, essentially siding with the state of Wisconsin. This is still being used on a daily basis, and information about the Compass software can be found on the Department of Corrections in the state of Wisconsin's website up to today. Which brings me to my next point. How can we tackle a situation in which a black box model is making such important decisions about people's lives? And as my cousin said yesterday when I presented this to him, he said, wow, that is Kafkaesque. So if you take one word away from that, I hope it's that. But a great word too is explainability. So the question is, can we audit a model so that it will tell us, here are the variables that I used to make this decision, and this is the decision that I landed on? And I'm going to introduce Python now because that is our common love here. There is a package called Lime, and Lime is available at this GitHub link down here. And you can use it to audit any model that you have built in Python, and it will give you a complete breakdown of the dimensions that were used and the features that were used to come to an assessment. It will also do image processing and highlight regions of the image that it used to come to its conclusion. So this example is actually just screenshotted off their GitHub, and this is saying you have a model that determines if a mushroom is poisonous or not poisonous. So the features are if it smells bad, the size of the gills, and some other mushroom-specific things that I don't understand. And then it says, okay, well, it smells bad, and that's the most important feature here. The gill size makes it more likely to be edible, and then these other ones are also important. And it says, okay, this is like, do not eat this mushroom. So this is a silly example because if you're in the woods and you're trying to eat a mushroom and you're turning to a machine learning model, you're already too far gone. But like, do not try this. But you can imagine if you do this with a more serious model, it will give you examples like age of first arrest, that's important. zip code that you grew up in, that's important. So there is this emerging field, which is less than 10 years old, of explainability in machine learning, which will sort of give us an audit report so that we know kind of what the machine is thinking in its head. On top of explainability, there's also bias mitigation, which is pre-processing in order to minimize the harm that a model causes. The example I chose to use here is IBM's AI Fairness 360, because you can just go online and play with it. There is an API, but there's a demo site that you can fire up and within 30 seconds have a model trained and an audit report for it. It has a variety of tools, data pre-processing and normalization, adversarial debiasing, which is really interesting for those of you in the ML world. It more or less uses a GAN network to try to debias some of the input data. And there's an online demo at this link. What's particularly relevant to it is that you can play with the compass data yourself at this website. And it will show you, using these different measures, there's statistical parity, average odds difference, disparate impact. And it will show you, these gray bars are more or less how biased the model was before, and the green bars are how biased the model was after the pre-processing. So in the case of, which one is the laser pointer? Yeah, got it. So in the case of this, disparate impact more or less tells you if for someone who is non-Caucasian, is the outcome of this model significantly worse? And the original is 0.75, where 1 is fair and anything below 1 is unfair. But after this debiasing, the fairness measure went up to 1.22. So you can sort of play with these statistical measures and get a better sense of what's going on inside of the system. And this is using the compass. I should point out the compass data is publicly available due to the court cases, but the inner workings of the compass algorithm are mostly approximated because it's still proprietary. Okay. So where do we go from here? I've just listed a lot of bad things that are going on, and I haven't given you really much of a solution except one Python package and something that IBM makes. I came up with this talk specifically for 3 things. One is I wanted to start a conversation. This is a topic that I have not heard in the workplace yet. If others have, I'm really happy to hear it, and I'd like to hear more about how it is being dealt with in the workplace. But there are many companies that are building models that are impacting even people who have never touched their software before, and I would be interested to hear how the employees and management are having a conversation around harm minimization. I would also hope that we all walk away with data analysis in mind, that anytime you are dealing with data, you are analyzing data, you are collecting data, there are going to be some sort of statistical biases baked into that data. You are always dealing with a sample of a population. And we should all start in the data science pipeline with fairness in mind from step 1. And part 3, the products that we make impact real people. There are real people on the other end, and we need to remember that we need to remember to be responsible, basically, for what we deploy out into the world. Now I'm going to tie it back to Legos. Everything comes back to Legos at some point. So at the beginning, we built a duck. And even the word duck is kind of funny. Like, they're silly, they have bills, they quack. They're the punchline of a lot of jokes. But when push comes to shove, they form cohesive social groups. They're pretty friendly. They eat stale bread. I don't know anyone who's like, I really hate ducks. Now, swans, on the other hand, swans are considered iconic and majestic. They've inspired hundreds of years of art and poetry. They're also those romantic swan rides at the carnival where you're sitting, if you know what I'm talking about. No one has a duck ride version of that. It's always a swan. There's a problem with swans, though, and it's that they're jerks. They terrorize other birds, they attack pets, they attack people. They're eye-catching and they're elegant, but they're just kind of terrible. And so if we can all walk away with one moral today. It would be that we should be building ducks and not swans. Because ultimately, we want our work to help people and improve society, even if it's not as sexy as a swan. So I deliberately left time at the end. I would like to take questions or comments if anyone is interested. I see hands. OK, I saw your hand first in the gray.
What does it mean for the fairness to be above 1.0 in the fairness policy?
Right. So the answer is it depends. Depending on the measure, let me go back to that slide. Yeah, I will. So you're talking about this, right? OK, so the question was, what does it mean for the fairness to be at 1.0 on this scale? And this is, or did you say above 1.0? Above 1.0 would mean that relative to a disparate impact, that you are actually, I don't want to say overcompensating because it means like it makes it sound like it's excessive, but it would mean that you are, compensating beyond a statistical baseline. So in other words, you would provide a preferable outcome to a protected class more so than a statistical average. Does that make sense? Yeah. Yeah, but it's a fair question. It's not a normalized. There's no scale in that. Yes?
What advice would you give to people here in the room who they may bring up to folks in their organizations issues about ethics?
Mm-hmm.
They get pushback from
Yep.
their leadership or from their managers saying that, oh, we might be compromising revenue or this
Mm-hmm.
isn't our priority right now. What kind of advice would you have for those people to actually get the conversation?
Yeah, that's a great question. And the question was, how would you get the conversation started in a workplace around fairness and ethics and machine learning, especially if you get pushback from management about, well, what about revenue and what about speed and accuracy, things like that. This is a really good question, and I really wish I had a silver bullet answer to it because it's the topic that I'm studying for my thesis at the moment, which is how do you align the motives of a management, so a profit motive versus the fairness motive versus the accuracy motive. How do you incentivize those three groups so that they can find a common solution? There's a couple of potential methods. One is if you can make the case that it somehow improves the product. And I'm assuming that you've already made the argument that like this is the right thing to do, and people have said we don't care, right? Just my inner pessimist. But the other thing is that there is the potential for embarrassment. Like we all know cases where models have been deployed, and then someone makes a Twitter bot and it says a bunch of terrible things, and the company gets embarrassed. We were talking about it at lunch, the Microsoft bot, but I don't remember what it's called. What was it? Tay, yeah. So don't be a Tay. That's they trained their model on Twitter data and then had it tweet back out into Twitter, which is like garbage in, garbage out, classic example. And then they're like, why is it saying terrible things? I was like, because you trained it on garbage. So that's always a powerful force. It's like getting embarrassed is bad for business. So it's a good. Yep. Oh, yeah. So the question was, do I think that there are situations where a black box model should not be used? In other words, there should be a person, and you should be able to understand what's going on inside. Yeah, and in fact, I think the Compass model is a classic example of where you should. Oh man, come on. Is a classic example of. Not even thinking about it like thinking about it as the defendant in a court case, to have to defend yourself against a score that was spit out by a computer that you can't actually judge well enough to argue against, I think is really untenable. I have 1 minute left, so I didn't see the 5-minute one. Okay, it's okay. The answer is yes. I'd be happy to talk to you afterward. Yeah, I saw one more hand. Yep.
Now that we're going to be using more models and data to kind of predict society more, like, instead of just perpetuating our biases with data?
Yeah, that's a great question. The question was, how can we use models to not perpetuate our biases moving forward to improve society? And I think a big part of that is if we can train our models consciously in a way that either oversamples in a certain way that we can kind of push the needle away from the direction we've been going in. And also if we can sort of, if we can have like open conversations about how the models are being trained and what data is being used, then I think that we can, I think that there is a possibility for us to, for example, in the criminal justice system, to make improvements. But right now, that is not what's going on. But I'm also happy to talk to you afterward because I'm out of time, right? Yeah, okay. Anyway, that's my talk. That's the first time I've given it, hopefully not the last. Thank you.